that exists between the two triangles, right? It's obvious that the angles are the same, right? So we got 30, 60, 90 to 30, 60, 90. To be in a unit circle, you only are allowed to have your radius be length 1. Okay, that's what makes it a 1 unit circle. Right? On a typical 30, 60, 90 right triangle, we know that our hypotenuse is 2. So how did I get from the 2 to the 1 when we're talking about symmetric triangles? It has to be a ratio. So what do I have to multiply by 2? Yeah. 1/2, right? So I am taking a half of each one of these sides to get my new sides on this triangle. Okay? So, what is what do I get when I divide 1 by 2? 1/2 would be that side, right? What do I get when I divide square root of 3 by 2? Just square root of 3 over 2, right? Which means that this coordinate right here, if I'm going out, square root of 3 over 2 in the x direction, and up 1/2 in the y direction. Right, we put that on the coordinate plane. Okay. All right, I'm going to go through and do the 3 triangles, and then I'm going to relate this back to our sine, cosine, tangent in a second. Okay, so now let's look at the triangle that says 45, 45, 90. Okay. All right. How do I get from square root of 2 over 2, or square root of 2 times what equals 1? You have to get it to equal to 1. What would I really need in the denominator here to make it equal to 1? Just 2? It would have to be square root of 2, so aren't I multiplying by that? So what I need to do is I need to divide these guys by square root of 2. Do you like the way that looks? What do we need to do? We need to rationalize, right? So it's really square root of 2 over 2. So we know that each one of these legs would be square root of 2 over 2. Which means that this coordinate right here is the square root of 2 over 2 out on the x. And if I were to go and look it up on the y, it's the square root of 2 over 2. One more triangle, and then I'm going to relate this back to sine, cosine, tangent. I have to get, all of it is I'm getting this triangle's ratio to scale down to this triangle. Right? There always has to be a 1 on that. Okay. All right, let's look at this one here. Should be very similar to one of the other ones we've done, right? It's just the 30, 60, 90 flip where the 60 degree is the reference angle instead of the 30 degree. Okay, so how did I get from 2 to the 1 of my simple triangle? 1/2, we divided by 2 basically, so I'm just going to divide both of those by 2. So this leg would be 1/2, and this leg would be square root of 3 over 2. So how many, in this case, how many are we going out on the x? 1/2, good. And how many are we going up on the y? And they look like weird coordinates, right? Because we're normal, we like integers, right? Instead of fractions. Right. So they cosine of y coordinate of this place to sine. I have to figure out how to use the other coordinate. Okay, there's some other things we need to talk about. Okay? Alright, but right now we're just going to set up the coordinates. Okay? So, I'm going to help you fill in your circle now. So you're filling in either your pink or your green ring, right? And remember how we weren't solving any that were on the quadrant angles yet? Today we're going to take care of that. So you're going to be able to do pi over 2 and pi and 3 pi over 2 and 2 pi fit. Okay? So we're going to use coordinates to solve instead of the triangles. Alright, so I still have my all students take calculus thing, right? Alright, then we've got our nice little angles in there. Already got all your angle measures in there. We'll fast forward through that part. This was what I usually do at the beginning of the year. Somewhere write down on that piece of paper that if it's not there somewhere, make sure you write cosine comma sine. Where the x is equal to cosine and the y is equal to sine. Okay? You know that information. Alright. Then we're going to put our coordinates on. So label that there. So your first coordinate here on the positive x-axis is 1, 0. And it's all based off of making sure you get these first 4 coordinates correct. Okay? Alright. This one is 0, 1. Meaning, remember, the radius length is 1 on the unit circle. That's why we're saying it has to be 1. Okay? Alright, then this one is negative 1, 0. And this one at the bottom is 0, negative 1. Alright, so I will not take credit for this. Do you guys remember CJ Hawkins? He was one of our male cheerleaders. Yeah, maybe. Yeah, it's been a while. So he was in my class, and he remembered his unit circle. So you have to get these 4 right. He thought that this looked like negative 10. It's not negative 10. Okay? And he thought that this looked like 10, and that's the way he remembered it. Okay? So he was able to get his points right. And then your zeros have to go to the other spots for the other 2. Okay? So that's my tip from CJ. Okay? If it works for you, great. I try to drove me nuts. I remember it was 1, 0. Okay. Then we've got to get these other ones filled in. And it's going to take a second. Okay, there we go. So this is, I'm going to go back 1 step. So I'm going to show you how to make this as easy as 1, 2, 3. Okay, all you have to do is remember 1, 2, 3. Right? So, see how that's 0? When we're counting, what comes after 0? 1. And then what comes after 1? 2. And what comes after 2? 3. So it goes 1, 2, 3. At some point, you're not going to get to use your circle. Not yet. But you have to know how to set this up. Okay? No, those are just numerators right now. Okay? Alright. Then, see how the 0 is in the x spot up here? So I'm going to count down. 1, 2, 3. Now, when we were writing our coordinates earlier, weren't all of them divided by 2? So we divide everything by 2. And then technically they all have square roots, but what's the square root of 1? 1. So I wrote square roots on everything that doesn't have a 1. Okay? So that was quadrant 1. I'm going to let you catch up on quadrant 1, and then I'm going to do the next quadrant. Let's see if we can at least get the circle set up.